All right, and this is question number 9, the last combustion question. And in this case, we're dealing with 11.19 grams of a compound. This one has CH and fluorine, and it's going to yield for us 24.62 grams of carbon dioxide and 8.4 grams of water. In this case, we're going to find the empirical formula and then the molecular formula because we're given the mass of the overall molecule per mole. So once again, we're going to use the CO2, or grams of CO2, which is 24.62 grams of CO2. And we're going to use that to find our grams of carbon. So if you want to see the slow version of this walked through, go ahead and watch the other video. But I'm just going to go ahead and set this one up and get the answer for it. All right, so with this setup, we convert grams of CO2 into grams of C. We find out that our original compound had 6.719 grams of carbon in it. Now we need to figure out how much hydrogen there was, and we're going to use our 8.4 grams of water that we collected and use that to convert over to hydrogen. So when we set that up, making sure to use multiple sig figs on the molar masses, we can see that there is 0.9402 grams of hydrogen. So the next thing is, if we have 11.19 grams of sample, and we know that there's 6.719 grams of it was carbon and 0.9402 grams of it was hydrogen, the other amount of this 11.19 will be the fluorine. So to figure out what the mass of the fluorine is, we're going to subtract the total mass from the sum of 6.719 grams of carbon plus 0.9402 grams of hydrogen. And that's going to get for us the mass of fluorine. And we find out that it's 3.531 grams of fluorine. So there we go. There is our 3 masses of the elements that make up this unknown compound, this unknown organic compound. We're going to take those 3 numbers now to a fresh page and use them to find the empirical and then molecular formula. So here's our 3 masses. We're going to take all of those and just convert them into moles using the molar masses from our periodic table. Being sure to use more than just 1 or 2 sig figs. Let's go all the way out if we can. So by converting them all into moles, we find out that there was 0.5594 moles of carbon, 0.9328 moles of hydrogen, and 0.1859 moles of fluorine. I'm going to go ahead and divide by the smallest, which would be the fluorine. So 0.1859, and that will give us our ratio. So it's going to be 3 to 5 to 1. So that means our empirical formula will be C3H5F. All right, so that's the empirical formula. That's the lowest ratio. The actual formula, so the molecular formula, we're going to have to figure out using this molar mass that we were given, the 300.4. So what we need to do is find the empirical mass of the empirical formula. So 3 carbons, 5 hydrogens, 1 fluorine. If we add those up using several numbers from a periodic table, the molar mass of this guy is going to be 60.07 grams per mole. So the conversion from empirical to molecular is the actual mass, the actual molar mass, divided by the empirical mass. So in the case of our numbers, the actual was 300.4 grams per mole, and our empirical was that one that we just found at 60.07 grams per mole. When we divide those two, we get a nice round 5. So that means the actual formula is 5 times greater than the empirical formula. So we're going to take all of these numbers in our empirical formula and multiply them by 5 to get our actual formula. So that would be C15, H25, F5. And there you go. We have both the empirical and the molecular formulas for this organic compound found via data from a combustion.